Hoi, hoi, it's me, Zozizi. Hello everyone, welcome to another offline stream. How about that? How about that? Bet you didn't expect that shit to happen yet again. It's gonna be happening every day until June 12th. And yeah, maybe, just maybe, on June 12th, is that how we say it? I don't know. I'm gonna be back on Twitch. But to be fair, the more I do these offline streams, the less I want to go back to Twitch. It's just like it's so pleasant in here. Just work on things without getting distracted constantly all the time, and it's just like very enjoyable. Not gonna lie, not gonna lie. So before we start, somebody once donated me. Well, not somebody, but it's actually a very specific person. Dusty Pawsey donated 10 euros saying, "Not motherfucker!" Pingu 1990. I do not fully understand this reference, but I like the quote. So thank you so much for such a generous donation. Really appreciate it. Thank you. So today we are continuing doing a game development in C++ and OpenGL. We were supposed to be doing that yesterday, but yesterday I decided to do web development. So today we're doing game development instead. So I just swapped the slots. The source code of the game. So this is how the game looks like right now. It's not finished. It's not a final look and feel. It's more of like a technological demo of my own engine. What the engine is capable of doing. It's a custom engine based on OpenGL. I think OpenGL 3 specifically. All right, and the source code can be found in here. It doesn't have any name. The game doesn't have any name. Right, the name is not known yet. Right, so this is the references, and this is the source code. You can find it in here. All right, so let us see what we can do today. So yeah, game does not indicate that wars.conf failed loading. So on the previous stream we were working on recovering from the failures of reloading wars.conf, and wars.conf is basically a file with the variables, the variables that control different aspects of the game, such as gravity, enemy speed, item size, player width and height, and so on and so forth. All of these like magical constants are consolidated in this single file, and we have a system that is capable of hot reloading this this file. So, and if we run this entire thing, right, for instance, what we can hot reload, let me see. So we can probably hot reload the gravity. That'll be actually kind of fun. So the current gravity, as you can see, feels sort of like this. So this is the current gravity, right? I can change the gravity to like half of its strength, and this is going to be the current gravity. I feel like I'm on the moon. Yes. So, and all of that is hot reloaded in runtime, but in release build, you can actually make these values compile time. So we have a special tool that generates meta information for these variables to hot reload it in runtime, and then it can also generate the compile time values to enable the compiler to optimize out all of these constants and like fold them and stuff like that. So yeah, basically that's what it is. So if you make any syntactical error in here, right, if you introduce any syntactical error, it's not gonna fail anymore because we fixed that, but it will tell you where exactly the syntactic error has happened. But here's the thing. When reloading wars config fails, inside of the game there is zero indication that something went wrong, which is not particularly convenient. I want some sort of like some sort of like a text saying, well, could not reload wars config because some syntactical error or not. Look into the logs, look into the standard output of the game, and then inside of the standard output of the game I'll be able to see that, right? So for example, if I use something like a type that does not exist, right, so it will basically tell me that is not a valid type, but the game itself does not indicate that something went wrong. So that's basically what I want to have. I suppose the easiest thing to do in this particular case would be to maybe, I don't know, display text. But the problem is that our game does not display text. Our game is incapable of displaying the text right now, and maybe this is something that we're going to work on today, enabling the game displaying the text, because later we'll need that capability of the game when we're going to implement the development console, right? So the Quake style development console, where you can issue commands, development commands and stuff like that. That kind of stuff will be extremely useful. So maybe that's precisely going to be the topic of today's stream. How about that? So I'm probably going to use Domson fonts yet again. Let me actually find them. So I'm probably going to use these fonts again because they're so convenient to work with. They're extremely convenient to work with. It's just like a simple sprite sheet that you load into your game, and it's super easy to find individual characters in there and just display them. So that's probably what I'm gonna use. So let me put this thing into the description just for you. Domson fonts, and there we go. All right, but here's the problem. So we need to work with them as textures, right? So, but we already have like a texture system. That makes any sense. Texture system. So essentially right now, like we have a lot of different textures, right? They're displayed inside of the game. You can see the textures of the player, the textures of the items, and the textures of the enemies and tiles and whatnot. But all of that is consolidated into a single texture atlas, right? Texture atlas. Texture atlas. Right, usually, yeah, so you consolidate everything into a single texture atlas. Right, and then you take that texture atlas and upload it as a single texture to the GPU, and then if you want to display different objects with different textures, you basically cut out that small piece and slap it on the object. So why it is usually done like that? Because of the limitations of the old versions of OpenGL, and maybe also limitations of the hardware. I think these days there are other options, but some people still do it like that. So what is the reason I'm doing it like that? Because I'm not a game developer and I'm learning things. So there's no particular reason why I'm doing it, like I'm making support for several textures through the texture atlas, except that I never in my entire life ever written a game engine with the texture atlas until I started this project. So, and I just wanted to try it out and just see if it works or not. I don't know, like if you expect some sort of arguments for and against this kind of approaches, you're asking the wrong person, I'm sorry. So, yeah, I don't know. So yeah, so we're gonna do that through the texture atlas. And the question is, what do I do with these sprite sheets? What do I do with this spreadsheet? Do I actually add it into my texture atlas? But then within the texture atlas, is my internet down or something? Oh no, it's not down. I think it's something with the open game art. All right, so what do I do with this thing? Do I put it into the texture atlas and... well, the problem with the texture atlas is that right now I actually enable like a linear interpolation and whatnot. Yeah, so basically there is linear interpolation applied currently on the texture atlas, and if we put this thing into the same atlas, into the same texture, the linear interpolation is going to be applied to the sprite sheet as well, and all of that will become super blurry, and we don't want this thing to be blurry. So maybe because of that, we'll have to... can I actually open this as an image? I can only download it as an image. All right, so let's quickly download it. Okay, let me actually copy paste this here. All right, and let's open it with Emacs. Why not? There we go. So basically, yeah, this is what it's gonna look like in the game. If I put it into the texture atlas, this is how it's gonna look like in the game. Because right now we have linear interpolation applied to the texture atlas, and probably because of that, we'll have to have a separate texture. Right, we'll have to have a separate texture. So the problem is I don't know how to work with several textures. I know how to set up a single texture, right, and just use it all the time. But if you have several textures and you need to switch between them, I have no idea how to do that. It has something to do with like a GL active texture or whatnot, or something like some different targets and slots, and I never actually researched how to do all of that. Maybe that's going to be the thing that I'm going to try to do today, like just see how to work with several textures. Maybe, you know, educational offline stream. Educational offline stream. So yeah, let's quickly do that. Let's actually learn how to work with several textures. So first, let's create like an empty program, right? Let's create an empty program that just loads one texture and displays that texture, right? Nothing particularly special, right? It doesn't do anything particularly special. So we're going to use our OpenGL template that I use all the time. It's written in C, not in C++. There's no particular reason for that. Don't look for any, you know, technical analysis of any of my technical decisions. I do things just because I find them fun. Okay, so and yeah, I'm gonna put it in the description just for you because I love you. OpenGL templates, but it's true, I do love you. All right, even if sometimes I don't show it, I actually love you. So what the fuck are we talking about? Yeah, so let's do git clone, and we're gonna clone it into multi-texture, right? Multi-texture. I should have actually run it asynchronously so we could see the progress, but I mean it was so fast, maybe the progress is not needed at all. Let's try to rebuild this entire thing, and is it working? Is it working? So this is how the OpenGL example looks like. It just runs a very simple fragment shader that animates the colors and whatnot and just makes a pretty picture so everyone can look at it and go, whoa, whoa. That's precisely why OpenGL was created, by the way. So can we actually now load some sort of a texture in there? What kind of texture do we want to load in there? That's a good question. So do we have some interesting textures in here? So PNG, we already used gbaited yesterday for our website. So I also have think. It's actually emote, right? It's actually Let's use emote. So how many amps? I'm gonna put 3 amps in here. So here's the here's the so this is gonna be our main texture. The second texture that we're gonna load, because we are doing multi-texture research education, the second one is gonna be the font, right? Because using these two things is gonna be super close to the setup that I have. I'm sorry, I'm Russian and confused sounds S and th and s, because we don't have a th sound in our language. But speaking of, how many languages a part of English have the th sound? Because a lot of European accents, they actually replace th and th sounds with s and z. So that means a lot of European languages don't have the th sound. So is the English the only language where you have a th sound? Or maybe there are other languages? I don't know. I'm not a linguist, so I'm genuinely curious. All right, so to load the texture, we need to be able to load PNG files. To load PNG files, I'm going to be using STB libraries from by Nothings. They're very simple single header libraries. They can work with images. You can load images. You can resize images. You can save images. You can do all other things. So you have a parallel noise, includes stuff like that. So there's a lot of things in here. I'm gonna put them in the description just for you, because why? Because I love you, exactly. So STB header only libraries, right? So let's capitalize everything so it looks pretty. So how are we going to be loading all of that? So where is my main program? Here is my main program. So we initialize this thing, we create a window, we make the current context, we do glue, we reload the shaders and stuff like that, and we're setting up all of the callbacks. Okay, so what I'm thinking is that maybe after we reloaded the shaders, I can do something like reload textures, right? So let's have a separate function that sort of similar to reload shaders, but it works with different objects. Right, so where is reload shaders? So here it is. Let's put it a little bit closer to here. So this function is not accepting any arguments, and there we go. Okay, so let's use STB. I didn't even load it. I didn't even download it. That's what I wanted to say. I just need to download this thing. Let me take the raw gachi version of this file. It's a huge file, girl. Holy shit. Yeah, raw gachi version of this file. Thank you very much. And I'm gonna just go ahead and download this entire thing right here, right now, right here, right now. Okay, and after that, I'm going to include the raw gachi version of this library and also define STB image implementation. So what it's all about, if you're curious why I include this entire thing, you can read about that in here. Well, they don't really explain why you have to do that. They just say that you have to do that. But the point is, it includes the implementations of the functions, right? So in C and C++, you have header files, you have C files. Header files contain declarations, and C files contain implementations. Since it's a header-only library, it contains both declarations and implementations. But sometimes you don't want this thing to act like a C file. Sometimes you don't want to include implementations, right? Because you want to control where implementations will go, like to which translation unit. In that case, you just don't define this thing in that specific translation unit, and you're always only going to have a declarations, but not implementations. That's precisely why you have to do that, so you have more control of where things go. Make sense? Makes sense. That's basically the, it is trying to circumvent the weirdness of C, C++ programming languages, right? Because these languages are so archaic. They were developed at the time where, well, I mean, I wouldn't say modules were not a thing, because Pascal is as old as C and C++, and it has modules, right? But to be fair, in my personal opinion, Pascal, did I say Haskell? I meant Pascal, actually, right? But Pascal was a little bit ahead of its time, to be fair. And my personal opinion, I think Pascal is better than C. Yeah, I do think so. I think it's better than C, and it's such a shame that that language lost the C versus Pascal war. So it's more semantically consistent. It has a stronger types, and yeah, better design decisions overall. I'm not talking about what came after Pascal, this expansions Objective Pascal and whatnot. I'm talking about the original procedural Pascal. I think I personally like Pascal, original procedural Pascal better than C. So yes, I am a weird person like that. So. Sorry. It's just my personal opinion. Anyways, but we stuck with this stuff, so it is what it is. Anyways. I used to do Pascal streams, by the way. Maybe one of these offline streams is going to be a Pascal stream too. I'm going to pick like an interesting topic and just implement something in Pascal. That would be actually kind of cool. So the pretty interesting successor of Pascal, I would say, is Ada. Right, Ada actually inspired a lot by Pascal, Ada programming language. This one. It's actually a pretty cool one. I did a lot of different streams on Ada. I think the most popular one is actually available on YouTube. It's when I looked into Ada a little bit closer. Ada, and I implemented Game of Life in Ada. So yeah, Game of Life in Ada. So maybe one day it's gonna have 1,000 views. I don't know, maybe, but yeah. It's pretty good talk. Basically, it gives you like the gist of the language. So I'm gonna put it into the description, just for you. Because why? Why? Because I love you, of course. So Ada stream with Sozin, right? And I think I lost that thing. I hope it is an Ada stream. HTTP. Let me double check. Let me double check. Yeah, Game of Life in Ada. Okay. All right. So yeah, getting back to C. Snap back to reality. So yeah, we included STB image, and now in STB image, right? In STB image, I should call something like STBI load, right? So, and that will load all of the pixels. Reload textures. Okay, so the first texture that we want to load is going to be texture, right? So let me do something like this. It's going to be PNG. So X and Y will give us width and height, right? And end will give us the amount of components in that specific images. Is going to be like either 1, 2, 3, or 4, like, you know, the amount of the channels, right? So, but one of the things you can do in STBI is that you can ignore this entire thing, right, and say, give me 4 components no matter what. Right, so essentially, I don't care what kind of image it is, right? Always convert it to 4 components, RGBA, because that's precisely what I want to use in OpenGL. So that's pretty convenient. So if data return null, that means we couldn't load this thing, and we can report an error, saying something like std error, error could not load this file, right? This file because this shit has happened. Okay, so maybe we're gonna do something like const char file path, right? So we have a file path, and we're gonna reuse this thing in here. So it's gonna be file path. So now could not load file path because str error no, and then we're gonna crash. There we go. So that's precisely what we're doing in here. So maybe in data, we're going to call something like pixels. And this one is going to be width. All right, so it's going to be width. This is going to be height. Okay, so let's put it like this. Width. Height. And there we go. We managed to do something. So maybe we also want to print something here. So file this, file path, there we go, and size is going to be d by d. Width and height. And let's try to recompile this entire stuff and see if it's gonna work or not. All right, so we still have a bunch of warnings in here. This is precisely because of like different conversions. I can easily fix all of that. And this one is because the reallog sized does not ignore alt size, right? So that's precisely why we have all of that stuff in here. The reason why I know all of that, the reason why I navigate inside of STB library so well is because I had to fix that specific error, that specific warning. So many times I know precisely where to go and what to look for. Yeah, it's kind of funny. Unfortunately, Nothings does not really look into the pull requests of STB libraries, so it's kind of pointless to submit any pull request to him. So yeah, if you want to fix this kind of warnings, you just have to fix them yourself. But the library itself is not broken, right? It's just like it relies on some, you know, implicit conversions and whatnot. So some compilers just throw warnings. So it's not that big of a deal. That's what I'm saying. It's not that big of a deal. All right. Okay, everything seems to be compiling, and let's try to run this thing and see if we manage to successfully load the texture. We did in fact successfully load it, and its size is 112 by 112, precisely what we expected. Isn't that amazing? I think it's goddamn amazing. My god, my god, my god, my god. So now we need to turn this into a texture. So I'm gonna steal some code from my game on how you turn things into the texture. I don't really understand how that code works, precisely because OpenGL was never designed to be understood. It's designed to be copy-pasted. So I just copy-pasted that code that works with textures from the internet, and I hope that there is no viruses in there. Yeah, anyway, so GL, yeah, so this is precisely where we do all that. So first thing we need to do, we need to generate the texture, right? And then we bind that texture as a 2D texture, and then we assign some texture parameters. Here we have like filters, like magnifying and minifying filters, like when you scale up and down. So we use linear interpolation here, as you can see. And then we also have texture wrapping. I suppose if you go like in your fragment shader, if you go over the texture coordinates, what's gonna happen? I suppose you can maybe wrap it around, or you can clamp it, so you cannot go to the right. So it's gonna always like the right or left edge, depending on where you sort of overflow it. And then we upload the texture image data into the GPU, and you can generate meat maps. I still don't understand what is GL active texture. Like, it probably is something about switching the textures, right? It's something about switching the textures, and I don't understand it. So, and this is precisely why I'm doing all of that. I just want to learn how to work with textures, and I'll do anything to learn about that, even read tutorials, because I absolutely hate reading tutorials because I cannot focus on reading a lot of text. But I want to learn this shit so hard, I'm gonna go against my my nature and just read a wall of text if I need to. I will try to avoid that, but if I need to, I will read a wall of text for sure, for sure, for sure. Okay, so we loaded this thing, so let me go to texture and let's generate the texture, I suppose. So we're going to have GL gen textures, so it accepts the number of textures that you want to generate. Can we see what's the output? Is it GL uint or just GL int? I would assume that is GL uint. Gen textures, okay. GL2, that's actually a pretty old function. So it's GL uint. Okay, so let's do something like GL uint texture. Right, so this is a texture. Texture. We're generating a single texture. After that, we bind that texture. Right, so bind texture, and we bind it as GL texture 2D. I suppose it's like an attachment point, like or maybe a target similar to vertex buffers, because vertex buffers are like usually GL array buffer or GL element array buffer or something like that. Yeah, it's called target. Specifies the target to which the texture is bound. Must be GL texture 1D, GL texture 2D, GL texture 3D dance game. And we also have a cube map. So I roughly know what is a cube map. but not really, and I don't think we need it in our game. All right, that's cool. So we bind the texture as 2D. So it's gonna texture, right? So we also need to set up the texture parameters. So I'm gonna just copy paste these parameters as they are. And then we need to upload the texture data to the GPU. So GL text image 2D, 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 2D. Okay. So target yet again is going to be GL texture 2D, GL texture 2D. The next thing we accept here is the level. What the hell is the level? Specifies the level of detail number. Level 0 is the based image level. Level n is the nth map reduction image. Okay, let's use the based one. Right, so let's just use a based one. Internal format specifies the number of color component in the texture. Must be 1, 2, 3, or one of the symbolic constants. Okay, I'm gonna assume that we are RGBA 32. Does it have RGBA 32 or at least 888? So does it have just RGBA? Oh, it does have just RGBA. So maybe I'm gonna just stick this thing in there, and yeah. So. And that's precisely what we're doing here, actually, so maybe that's fine. Okay, width and height is actually pretty straightforward. Specifies the width of the texture image, including the border of any of the GL version. Does not support non-power of 2 sizes. This value must be to n plus 2 border for some integer n. All implementation sample texture images that are at least 64 texels wide. Well, interestingly, our image is not power of 2, so it's 112 by 112. But I still quite often manage to upload it anyway, so I don't know. Let's just set it to whatever width we have. So I'm gonna do width, and then we're gonna have height. So also we have a border. Specifies the width of the border must be 0 or 1. Okay, so we don't need a border, I suppose. The format specifies the format of the pixel data. The following symbolic values are accepted. So I suppose the internal format is the one your data in, and this format is the one the OpenGL will output, probably. Not quite sure. But in any case, I'm gonna just set it to RGBA. So I'm gonna just set it to RGBA, and let's take a look at the type. Specifies the data type of the pixel. The following symbolic values are accepted. What do we use here? We use unsigned byte. So the pixel data. Man, we can just do unsigned. I suppose it's like for a single component. Right, and after that we're gonna apply pixels, right? We apply pixels, and we should be good to go, right? We should be good to go. And let's see if we successfully created shit. We're gonna print something like successfully created texture, and I'm gonna print the texture itself is gonna be texture. I'm gonna specifically print the texture ID. Right, there we go. So here is the texture ID. Let's try to recompile this entire thing and just run it and see if it's gonna be okay. All right, so successfully loaded shader, so created texture 1. Nice. So that's already pretty pogue. That's already pretty poggers. So can we now use this kind of thing in our shader? So do we even have any shaders? Yeah, we do have some shaders. Like specifically, I'm looking for main frag. As far as I know, you're supposed to use something like a sampler, right? Sampler 2D or whatnot, right? So let me take a look at my code in my game. So in my game, I have a shader with a rect frag, and it has a sample, yeah, sampler to D, right? So this is basically through what I access the texture. And then I call the texture function, I supply the sampler, and then I supply the coordinate of like texted coordinate or UV coordinate or whatnot, right? And that picks the right color and just gives that color to you so you can transform and do some things with it. Right, so that's essentially what we're doing in here. And let's go to our fragment shaders. So it's going to be uniform, and let's call this thing, I don't know. Let's call it image frame, something like this. So here we have different colors and whatnot, and what I want to do, I want to probably have UV coordinates, right? So we don't know anything about UV coordinates. Maybe we should actually pass them from the Vertex shader. So, oh yeah, so we do have UV coordinates. So let's actually do something like out vec2 UV, and we can generate those UV coordinates in here, right? Actually, this entire thing without this kind of transformation is UV coordinates, because UV coordinates are 0, 1, 0, 1, and GL vertex ID is the value from 0 to 4, right? It's a value from 0 to 4, 0, 1, 2, 3, right? And essentially what we're doing in here, we are interpreting the bits of these values, as the coordinates. Right, as the coordinates. And as you can see, these coordinates go from 0 to 1, and we go through all of the coordinates of the quad. So that's precisely what we're doing in here. So I can take this entire thing, and interestingly, I don't have to convert any of this stuff to floats, even though all of that is an integer arithmetic, which is kind of weird, but okay, maybe vec4 just automatically does that for you, but okay. So I can assign something like vec2, and it's going to be uv, and it's going to be vec2, and this is going to be like that, and there we go. So we have a uv. So now the thing I can do instead of these two lines is just do 2 multiplied by uv minus 1, and I wonder if it's gonna work. We'll see. We're about to find out. We're about to find out if it works or not. If it doesn't work, we'll probably have to do something like this, but I don't want to do it right now. I just want to see if it's gonna work. As it is, all right. So if I try to run it, I want to recompile it and run it, and it doesn't work. As you can see, that basically means a compilation error of the shader could not implicitly convert operands to arithmetic operands. Arithmetic must be numeric, cannot construct 4 from non-numeric. Okay, that makes sense. That's precisely what I would expect. So that means we need to convert this thing into something like this, right? So that's precisely what we need to do in here. Is it gonna work now? Is it gonna work now? Yo. It still doesn't work. Nice. I wonder if I have to actually make this floats. You know what? I forgot that I have a hot reloading. I really forgot that. Okay, so yeah. So essentially, basically, one of the things I can do in here is just do that and then refresh it. And as you can see, it indicates the error, and then fix it, and it works yet again. Okay, I forgot that I have a hot reloading, and I closed it again. Zozin, why are you so stupid? Why are you so stupid? Okay. Now, we're gonna go to the Fragment Shader, right? We're gonna go to the Fragment Shader. We already pass the UV coordinates, and here we just need to accept UV coordinates, right? We're just accepting the UV coordinates. And now what I'm going to do, I'm going to do a texture. Texture, what do we have? An image. So here's the image. I'm going to put an image in here. I'm going to use the UV coordinate. I'm going to multiply this kind of stuff. And boom, doesn't work at all. That is so nice. I wonder why. I think this is because I had to generate meep maps or something. I remember having this kind of problem in my game until I generated meep maps. So yeah, let's try to generate them. Let's generate flip-flaps. Let's generate some flip-flaps, and maybe it's going to work. Yes, it kind of works. You can see like the red color and whatnot. But It's kind of interesting, actually. What the hell is going on? Is that because I never converted this kind of stuff to... You see, I have this variable defined here, and then I define another variable. Oh boy, oh boy, oh boy. Okay, it's working. We managed to load a single texture. Not bad. Not bad at all. Not bad at all. Oh shit. Just a second. I think I did a fucky wacky oopsie doopsie. So, yep. Cool. Now, I want to load the second texture. So maybe one of the things we're gonna do in here is probably extract some of this code so we can reuse it for the second texture, because like it will involve a lot of copy paste. So maybe it would be better to introduce some sort of an image, right? So an image is going to have width and height, right? And also it's going to have pixels, right? It's going to have pixels. And then we want to have something like a load image from file, right? And then you provide const char file path, and yeah. So, and let's copy paste everything related to loading the file there, right? Let's just load it there. So here we're gonna have a result. It's gonna be 0 initialized, right? There we go, 0 initialized thing. Then I'm gonna return the result like this. We don't need any of this stuff, I suppose. Well, I mean, we need this kind of stuff. I'm just thinking, is it dangerous to do something like this? So you have a width, all right, you have a width, and then you have a height, and then you provide the file path, and then you actually save pixels in here. Is this an undefined behavior, though? Actually, kind of interesting. Shouldn't be, right? Shouldn't be, I think. Right, because we're passing some of the parameters, some of the parts of the texture into the function that will modify some of this part of the texture, and then the result of this function is applied back to this structure that could be modified by this function. So you see, it's kind of like a weird thing. And as far as I know, this kind of code does not even compile in Rust. Right, so this kind of code does not even compile in Rust. We can actually test it out. So it's going to have mine or s, and imagine that you have something like struct image, right? You have a struct image, and you have things like width and height. It's going to be use size, and it's going to be use size. And pixels, let's say that pixels are vec2, oh, not vec2, but vec u32, right? And all that has to be something like this, right? All that has to be something like this. And imagine that we have a function load image from file, right? Actually, let's literally call it like stbi load. It accepts file path, right? Accepts file path, which is going to be str. Then it will accept width, which is a mutable usize, right? It's going to be width mutable usize. Right, height, this thing, and it will return you a vector of pixels, essentially, right? So let me actually collapse everything. I don't know, man, I don't know. Okay, so What the fuck am I struggling with? Anyway, so I'm not going to implement that because it doesn't really matter that much. But now if I try to call this function, right? So if I have a mutable image, right? So here's my immutable image. So I suppose I have to initialize this kind of thing with something, right? I have to initialize it with something. Pixels, and I'll have to initialize the vector, of course. I have to initialize the vector. Can I do FMT now? Rust format buffer. Okay, so it still decided to actually straighten it out. Okay, sure. Sure, buddy, sure. So now I want to do something like stbi load png, and then I do image. Image is mutable, so I'm borrowing the part of the structure as mutable, then I'm borrowing the other part of the structure as mutable, and then I assign the pixels from this thing back to the image. Right, there's nothing like logically, in my opinion, wrong with this code, but in Rust it may not compile because borrow checker might not be happy that I'm actually borrowing the same structure for writing twice, but it's for different parts of the structure, right? It's for different parts of the structure. Right, so if I try to do that, it's probably going to tell me something about that. Maybe these days it's going to work. Oh yeah, these days it works. Nice. Beautiful. So, because I remember like partial structure borrowing was a huge pain in the ass in Rust, so I suppose it's fixed now. So the first time I tried like Rust, it was in 2016 and had a lot of problems. So they're fixing them, I suppose. So yeah. Nice. So it recognizes that these things are like separate things, and overall it's working. Okay, sure. Okay, so let me continue. So we have that, and yeah. So let's see if I can now do something like this. So it's gonna be image, and I'm gonna try to load image from file. We're gonna provide the file file path. Right, here is a file path, and there you go. So we can remove this entire thing now. Right, so this is a texture, and in here I can do something like width, height, and pixels. Right, width, height, and pixels. Let me recompile this entire thing. I'm not recompiling Rust, excuse me. I'm recompiling C. Thank you very much. So this one has to be just a file path. And yes, everything is working. So now we have a separate function that basically loads everything from a file and puts everything into a structure so we can use the structure. So the next thing I want to do, I want to extract this to like a separate thing. So let's call it like this: image as GL texture. So, and we're gonna accept the image in here, right? We're gonna accept the image, and so I'm gonna just copy paste this entire stuff in there. GLU int texture image as GL texture, and it's gonna be just Right, let's remove that. So this one should be a result in my opinion. I might as well actually query replace this right away. So this is going to be just the result, and that result is going to be returned in here. There we go. So do we need anything else? In this case should be replaced with result. Boom. And cool. Let's try to recompile this thing. So result, this one, image, unused variable, and everything seems to be working. Okay, so now we have functions that we can just call. All right, so let's try to load the second texture. Let's try to load the second texture, which is the font, but we want to try to load it with different parameters, with different like filters, because we don't want this thing to be blurry and whatnot, right? We don't want this thing to be blurry. Yesu. Image font, load image from file, const char font file path, and the name of the font is this thing, right? So here it is, font file path, there we go. So I wonder if it makes sense to actually split it like that, and then we're gonna have gl uint font font texture, image as gl texture, and it's gonna be font, there we go. And what's gonna happen in this particular case? Okay, so now it is using the font one, right? Now it is using the font one. So interestingly enough, I don't want to use linear interpolation for the font. So let's actually introduce some sort of like a Boolean flag, which basically indicates what kind of filter we're going to use, whether we're going to use a linear one or not linear one or something like that. Pixelated, right? So and the home texture is not going to be pixelated, right? But the font is going to be pixelated, right? So we're going to have something like this. All right. So, and if pixelated, we're going to set the filters. We're going to set the filters to nearest, essentially. Right. That's what we're going to do. We're going to set the filters to nearest. So, yep. Nearest, there we go. And is it gonna work now? It is working, so as you can see, it's not pixelated anymore. But again, how do we switch between the textures? How do we switch between them? That's a good question. That's a very, very good question. Wish I knew. So maybe this is precisely what GL active texture does. It just switches the thing, GL active texture, right? GL active texture. And what's going to be the active texture? So select which texture unit subsequent texture state calls will affect. The number of texture unit and implementation supports depends on at least 2. Okay. Errors associated gets. Okay, let's take a look at this tutorial. All right. Let's take a look at the tutorial and try to understand how we're supposed to use this entire stuff. Oh boy, where is my so maybe I'm gonna just start reading this entire. Okay, so we have several textures here, so this could be a very good tutorial. And again, I'm gonna credit this tutorial in the description, of course. So where's my description? And this is gonna be this OpenGL textures tutorial. There we go. So let's try to read that. Even though I don't like to read like huge walls of text because it's difficult for me, but let's quickly do that. Hopefully I'm not violating any copyrights. So we'll consider this a transformative work. All right. Please, the authors of this website, don't sue me. I credit you in the description. All right. Textures, objects, and parameters. Just like VBOs and VAOs, textures are objects that need to be generated first by calling a function. It shouldn't be a surprise at this point what this function is called. GL, again, textures. And we did in fact call this function. Textures are typically used for images to decorate 3D models. But In reality, they can be used to store many different kinds of data. It's possible to have 1D, 2D, and even 3D textures, which can be used to store bulk data on the GPU. An example of another use for texture is storing terrain information. Yeah, so you can basically use the brightness of each pixel as the height of some sort of like point on the grid if you generate a terrain. That sounds like a pretty cool topic for a stream. Wait a second. Wait. You generate terrain. You can generate terrain in the Vertex shader, right? You can generate terrain in the Vertex shader, but the texture is usually used in the Fragment one, but it's usually accessed via the uniform anyway, right? It's accessed via the uniform anyway. So, in a Vertex shader, you can take a vertex attribute, some sort of vertex attribute position, map it to UV coordinate of the texture, and take the pixel in a vertex shader and holy shit, I want to try to do that. It's so fucking cool. I just realized I didn't turn on my main lights in the room. I'm sorry. This is so cool. I want to try that. This sounds like a pretty cool topic. Forgive my excitement as I'm not a game developer, so a lot of things that I do with OpenGL I discover like for the first time, right? So anyway, storing terrain information. This article will pay attention to the use of textures for images, but the principles generally apply to all kinds of textures. GL bind texture, GL texture to dtext. So yeah, essentially it's like a general pattern in OpenGL. You generate an object and then you bind that object, and that object becomes sort of active object, and you the subsequent calls modify the state of that bound object. So we know that. Just like other objects, textures have to be bound to apply operations to them. Since images are 2D arrays of pixels, it will be bound to the GL texture 2D targets. The pixels in the texture will be addressed using texture coordinates during drawing operations. These coordinates range from 0 to 1, where 0, 0 is conventionally the bottom left corner and 1, 1 is the top right corner of the texture image. The operation that uses these texture coordinates to retrieve color information from the pixels is called sampling. There are different ways to approach this problem, each being appropriate for different scenarios. OpenGL offers you many options to control how this sampling is done, of which the common one will be discussed here. Nice. Very, very beautiful. I love it. I love it. Thank you very much. The kitty cross. I like this kitty cross. I wonder if I can just open it. Yeah. It's really. I thought you had for you could have just. Why is it not 4 separate images? This is what happens when graphics engineer, like a low-level graphics engineer, is trying to do web development. This is basically what happens. Yeah. Okay, so let me see. Let me see, Betty. Let me see. The first thing you'll have to consider is how the texture should be sampled when a coordinate outside the range of 0, 1 is given. OpenGL offers 4 ways of handling this. I actually mentioned that, you know, when I was looking through these things, like I was speculating, what do you need that for, right? It's basically, and I came to the conclusion that this kind of thing is needed to know what's going to happen if you go outside of the boundaries of the texture, and it was confirmed by the lovely open.gl texture tutorial. Thank you so much. GL repeat. The integer part of the coordinate will be ignored and a repeating pattern is formed. GL mirrored repeat. The texture will also be repeated, but it will be mirrored when the integer part of the coordinate is odd. GL clamp to edge. The coordinate will simply be clamped between 0 and 1. Clamp to border. The coordinate will fall outside of the range will be given as the coordinates that fall outside the range will be given a specified border. I was always wondered, like, what the hell is border in GL texture 2D, GL text 2D? Okay. All right. I know that reading documentation is very useful. And you can discover this kind of things, but man, it's difficult for me. It like feels like a chore. Like, I'm sorry. It's just like my brain works differently. I cannot read a huge amount of text. I'm sorry. So, and this, like usually in GL text image 2D, you supply some sort of a border. And I wonder if that's the border that is talked about here. So basically you can specify like the border that will be used for that specific image, but you basically say the width of the border, but the question is like what's going to be the color of the border? How do you specify that color or something? I don't know. I don't plan to use that anyway, so I don't really care about it too much. So okay, these explanations may still be a bit cryptic, and since OpenGL is all about graphics, let's see what all these cases actually look like. Okay, so that makes sense. Makes sense to me. Yeah. Thank you. Thank you for a single image of 4 images. The wrapping can be set per coordinate, where the equivalent of XYZ in the texture coordinate is called STR. Ah, I thought it's called UV. Okay, I'm not a graphics engineer, I'm sorry. Texture parameters are changed with the GL text parameters. Okay, functions as demonstrated here. So since it's a 2D texture, we're using ST, but in 3D texture, you're also going to be using R, and I'm pretty sure there is a constant that looks like this, like wrap R. Yeah, it is. So yeah, that makes sense. So you have STR. And what do they stand for? Well, XYZ don't stand for anything else, so maybe this is the case. Yeah, so they're actually in the same order like as the... Are they in the same order as the English alphabet? English alphabet. Because XYZ is basically taken from the English alphabet. It's XYZ last letters. So ST... Yeah, so if STR is like following the same logic, they're in different order, right? So ST and then R basically before, but they kind of like near each other. So yeah, but anyway, whatever. I don't think understanding the logic behind this naming is particularly useful for this specific case. As before, the I here indicates the type of the value you want to specify. If you use GL clamp to border and you want to change the border color, you need to change the value of texture border. Ah, this is how you change it. So basically through GL texture image 2D, you say, we're going to have a border, right? It's either going to be 0 or 1. And then through the subsequent GL texture parameter I, you specify that color. Okay, fair enough, I suppose. Fair enough. So as before, the I here, okay, so we already read that. Okay. So here's the border. We're not going to use border. This operation will set the border color to red. Thank you very much. Very cool. I love red. As you can see, I absolutely love red. I'm also Russian. I must be loving the red. Yes, the color of communism. Okay, filtering. Since texture coordinates are resolution independent, okay, they won't always match a pixel exactly. This happens when a texture image is stretched beyond its original size, or when it's sized down beyond its original size, I suppose, as well. OpenGL offers various methods to decide on the sampled color when it happens. The process is called filtering, and the following methods are available. GL nearest, returning the pixel that is closest to the coordinates. GL linear returns the weighted average of the 4 pixels surrounding the given coordinate. GL nearest mipmap nearest. GL linear mipmap nearest, nearest mipmap linear, and linear mipmap linear. Okay, so it basically samples from meep maps instead. Sure. Before discussing meep maps, let's see the difference between nearest and linear interpolation. The original image is 16 times smaller than the rectangle it was rasterized on. So far, no information on how to switch between the textures, but it's kind of interesting. It's kind of interesting. Is this the same, like a single image instead of like two of them? I have this problem yet again when I cannot press the right click. I'm trying to press right click and it disappears right away. And it's not a hardware problem, by the way. It is not hardware problem. It's something in my setup in the software part. I can start a different application that can handle right clicks, right? And it works there. And after I did one right click in that application, I can go back to my Chromium and it works again. So it's definitely not a hardware, it's something software, and using a different application from Chromium usually fixes it somehow. And is it a single? Yeah, it is in fact a single image, as you can see. It is in fact a single image. So can we just search for GL active? Okay. Okay, so maybe we should read this thing instead, because this is what I care about right now. Even though, like, we have a lot of interesting details here and there, the thing that I care the most right now is GL active texture and texture units and stuff like that, and how to switch between the textures. And this seems to be like the thing that I actually want to do. To be fair, maybe we don't really have that much text. Maybe we don't have that much text. To be fair, it's actually not that far from what I want to do, so maybe I can read the entire thing. The whole article is not that big. The whole article is not that big. So what I'm thinking, boys and girls, I'm already streaming for 1 hour, so I'm going to make a small break. And after the break, we're going to continue reading this beautiful tutorial. And yeah, by the end of the stream, maybe we'll learn how to work with textures. Sounds like a plan. Sounds like a plan. All right, so let me see. You guys want to listen to some music? Some smooth jazz, you know. Nice. 3 minutes. 3 minutes. No more or less. Could be a little bit more. Depends. It all depends. Alright, let's make a small break. Have fun. Yo. A little bit earlier than usual, please forgive me for that. So I put up my kettle and I'm just waiting for it to boil up my water, and in the meantime I'm gonna prepare the tea. Okay. While linear interpolation gives a smoother result, it isn't always the most ideal option. Nearest neighbor interpolation is more suited in games that want to mimic 8-bit graphics because of the pixelated look, and that's exactly what I was talking about. So for our font, because it's such a bit like pixelated bitmap font, we want to use the nearest interpolation. You can specify which kind of interpolation should be used for two separate cases: scaling the image down and scaling the image up. These two cases are identified by the keywords GLTexture min filter and GLTexture max filter. Makes sense, it's self-descriptive, right? So the names so far are self-descriptive, which is cool. As you've seen, there's another way to filter textures: meepmaps. Meepmaps are small copies of your textures that have been sized down and filtered in advance. It is recommended that you use them because they result in both higher quality and higher performance. My tea is ready, by the way, so I'm gonna go pour myself a cup of water and I'm gonna be back and I'm gonna continue reading this beautiful tutorial. Absolutely love it. My God. The music that plays when you set the border to red. GL generate meepmap GLTexture 2D. Okay, so we do call this thing. Generating them is as simple as calling the function above. So there's no excuse for not using them. There's no excuse. Note that you do have to load the texture image itself before meepmaps can be generated from it. To use meepmaps, select one of the 4 meepmap filtering methods. Nearest meepmap nearest uses the meepmaps that most closely matches the size of the pixel being textured and samples nearest neighbor interpolation. Linear meepmap, okay, so it basically, uses meepmaps that most closely matches the size of the pixel and samples with the nearest interpolation. So it's basically different combinations of meepmap nearest and linear. I see, it's just like, yeah, usually you may want to like play with them to see which one is gonna look better in your image. It sounds like something that maybe I should try to do at some point, like just pick one of these things and see which one looks the best. There's some other texture parameters available, but they're suited for specialized operations. You can read about them in the specifications. Okay, I see. So basically the article tells me I'm too stupid for them. Anyway, I'm joking. Loading texture images. Now that the texture object has been configured, it's time to load the texture image. This is done by simply loading an array of pixels into it. Right, so we've got 4 pixels, I suppose, yeah. And we just call GL image. We already did that. The first parameter after the texture target is the level of detail, where 0 is the base image. This parameter can be used to load your own meepmap images. Oh shit! I see. Okay. So why, like, I was always wondered, why the hell do you need the level? And to explain why the hell you need the level, you don't even need to explain this much. So you can just take this single sentence and put it in like after this documentation, and documentation will become 100% more useful. 100% more useful. Like Maggot is more useful because like why I was always looking at this thing. I was wondering, why do you need that? How do you use that? What the hell? And it's like, it's just like, okay, at that level, this thing becomes meat map. So, all right, yeah, okay. So, all right. The second parameter specifies the internal pixel format, the format in which pixels should be stored on a graphics card. Okay, so I confused it. I thought this format is the format of my pixels of my data. Apparently, it's the GPU's one. Okay, so but since I set both of them to RGBA, it doesn't really matter which one is which. So in my case, it always worked. So many different formats are available, including compressed formats. So it's certainly worth taking a look at all the options. The third and fourth parameters specify the width and height of the image. The fifth parameter should be always have a value of 0 per specification. Fifth parameter. 0, 1, 2, 3, 4, 5. Border. Should always have 0 per specification, probably because you control borders via the GL text parameters. Okay, so I thought before you can use the wrapping based on the border, you have to set the border to 1 and then set the color of the border through GL text parameter I. But apparently this is some sort of like obsolete parameter in here. So okay. The next two parameters describe the format of the pixels in the array that will be loaded, and the final parameter specifies the array itself. Okay, so it's actually not that difficult to remember. So the format that is closer to the data, related to the data, right? So, okay, so basically everything related to the user data is grouped together into these three parameters, and that's why this is the format of the pixels, and this is the format that is going to be on GPU. Okay, makes sense. Makes sense to me. Okay. But maybe border is like has nothing to do with wrapping around the texture. Maybe it's a completely different thing, and who knows? I don't know OpenGL. I'm sorry. So the next two parameters describe format of the lens. This is pixels. The function begins loading the image at coordinate 0, 0, so pay attention to it. But how is the pixel array itself established? Texture and graphics application will always be a lot more sophisticated than simple patterns and will be loaded from files. Best practice is to have your file in a format that is natively supported by the hardware. But it may sometimes be more convenient to load textures from common image formats like a JPEG or PNG. Unfortunately, OpenGL doesn't offer any helper functions to load pixels from these image files. But that's where third-party libraries come in handy again. The soil library will be discussed here along with some of the alternatives. My God. Is it developed by the creators of this tutorial? I don't know. Nice library, bro. So what I personally recommend is just use STB, seriously. Like, it's the easiest thing to use. If you're programming in C and C++, like just use STB image. It's a very lightweight, like a single file that just lets you just load the PNG file. Of course, it's not applicable for more sophisticated use cases. Yes, it is not applicable for more sophisticated use cases. For instance, it's really difficult to use this kind of library in a browser where you're supposed to progressively display PNG files as you load them from the internet, but this library was not designed for this kind of use cases. And when you just load the texture into OpenGL, it is exactly not that kind of use case. Yes, nobody's claiming that this is a general purpose library. It's a small library that actually suits really well for like small applications and small like multimedia games that just needs to load a PNG into a texture. For these kind of cases, it is perfect. For this kind of cases, it is perfect. It is not applicable for all of them, but for this specific case, it's just perfect. I already put the STB libraries in the description. Check them out. They're pretty cool. Anyway, so soil. Can we just skip this entire section? Can we just skip this entire section? Do they even mention STB? Excuse me. Do they even? They don't even mention STB. Disgusting. Fucking disgusting. I'm joking. All right. So we're not gonna read this section. We already know how to load images into textures. We literally did that. Using a texture, as you've seen, textures are sampled using texture coordinates, and you will have to add these as attributes to your vertices. Let's modify the last sample from the previous chapter to include these texture coordinates. The new vertex array will now include the ST coordinates for each vertex. In our case, by the way, in our example, we don't need that at all. Seriously. So if you take a look at this thing, I'm using something called GL Vertex ID to generate texture coordinates. I don't have to supply the texture coordinates to the to my shader program because I can generate it on the shader program. It's not always possible in all of the cases, but in our small simple case it is possible, so I can actually simplify the whole setup. So if you look up GL Vertex ID, right, GL Vertex ID, it basically gives you an integer number of the current vertex. Right, it gives you integer number of the current vertex. So essentially, we're rendering 4 vertices because we're rendering a quad. Right, we're rendering 4 vertices. So this is going to be 0, 1, right, and then this one is going to be 2, and this one is going to be 3. And yet again, if you take a look at the binary representations of these numbers, you will see that this one is 0, 0, this one is 0, 1, 1, 0, 1, 1. And there you go. Here are your texture coordinates. Yes, you basically, if you have GL Vertex ID, you have the texture coordinates for free. You just have to take this indices and you have to extract those texture coordinates from the bits. And that's precisely what we're doing in here. So yeah, by dividing it by 2, I'm taking the second. By doing mod 2, I'm taking the first one. Right, and there you go. So then I use it as UV, then I construct the position, and I also pass it to the Fragment Shader. Right, I pass it to the Fragment Shader, and in the Fragment Shader, I actually take the pixel of the texture. So for simple examples, I don't think you need to do this kind of stuff, but I mean, it depends. This is why I don't really like these tutorials, OpenGL tutorials, because they overcomplicate things. Like, to demonstrate textures, you don't need to fiddle with these VBOs and VIOs. You can just generate them on the GPU inside of the shader, but at the same time, maybe doing it like that is not educational. I don't know, maybe for some people it could be confusing, like generating this kind of stuff on the GPU, because not everyone is knowing like bit representations of the number and how to generate it. But again, if you don't know this kind of things, why are you trying to learn OpenGL? Because OpenGL is like a very low level thing, and if you just want to make a game, maybe just should use like an engine or something like that. It's just like, what's the target audience of these tutorials? Right? I don't know. It's kind of weird. Anyway, let's keep reading. So let me actually sip my tea because I have a dry throat. So yeah, we're supplying this kind of stuff. The vertex shader needs to be modified so the texture coordinates are interpolated over the fragment. well, yeah, we just need to pass it from the vertex shader to the fragment shader, and by passing them, it will automatically interpolate them. Just like when the color attribute was added. Oh, okay, so we're setting up the attributes in here, so it's not really that important in our case, because again, we're not passing this information via the vertex attribute, we're not passing it from CPU, we're generating the information on the GPU itself. All right, so yeah, this is just like a setup, and all right, so I think we can like easily skip all of that, because this kind of stuff is not applicable to us, because yet again, we're not passing this information to GPU, we're generating it on GPU, we don't have to do any of this stuff, right? So as you can see, you can solve problems by adding complexity, or you can solve them by removing complexity. So yeah, we decided to go the way of removing complexity. Again, it's not applicable generally, but for that specific case, it's just easier to do that on GPU. Yet again, not claiming that things are generally applicable. All right, texture units, the most interesting part, finally. So I should have actually skipped everything and just jumped into the texture units, but I decided to read it anyway, because I mean, hey, what not, content. So the sampler in your fragment shader is bound to a texture unit 0. Texture unit are references to the texture objects that can be sampled in a shader. Textures are bound to texture units using GL bind texture. Texture units are references to texture objects that can be sampled in a shader. Textures are bound to texture units using GL bind texture functions you've used before. Because you didn't explicitly specify which texture unit to use, the texture was bound to GL texture 0. That's why the default value of 0 for the sampler in your shader worked fine. I actually knew about that. I actually knew that there's something about like texture unit, and that the default value in the sampler just happened to work, and that's why I never worried about that. So, but then it never actually motivated me to learn about the texture units. So the function active texture specifies which texture unit a texture object is bound to when GL bind is called. Okay, so maybe that's precisely what we want to do. If I want to use the next texture unit, I probably have to do something like GL texture 0 plus 1, right? So let me actually see. Do I do like something like plus? Oh, there is a texture GL texture 1. How many of these do you have? Wait, let me see. So does it have it like for all of the supported ones? Okay, so what if I GL texture 0 grep or n? All right, so okay. Oh, you have 32 of them. All right. Makes sense. Cool. And I do remember they were talking about something like at least 32 per specification or something. Let me take a look at it. GL active texture. Here is the GL active texture. And so there was something like at least. At least 2. Was something 32? Nah, I think I'm actually imagining things. Whatever. The amount of texture units supported differs per graphics card, but it will be at least 48. Oh, okay. It is safe to say that you will never hit this limit in even the most extreme graphics applications. To practice with sampling from simple multiple texture, let's try blending the textures of the kitten and one of the puppy to get the best of both. Oh, you can actually have like several samplers in here. I see. The mix function here is a special JLSL function that linearly interpolates between two, well, I mean, I know what it is. So, and I suppose basically, yeah, I have to set the uniform of the sampler to the corresponding number to be able to switch between them. Okay. Okay. All right. I guess I do understand what's going on in here. So essentially, so if my texture is bound like that, right, I want to do something like GL active texture, and I just set a GL texture 0, right, and then after that this one is going to be GL texture 1, right, and because of that, right, so right now if I just run the application without reloading it, it shows the second texture because I think second texture sort of overwritten the first one, right, but now we put this thing on a separate texture unit and this also on its own texture unit, and default value of the sampler, the default value of the sample is going to be 0, so we're going to be back at the first texture. So we're going to be back at the first texture. Let me recompile everything and let's see what's going to happen. No, we're not. So that's not what I thought it is. Interesting. Interesting. Why was it not in there? They set the active texture before actually binding it. All right, so first they do active texture and then they bind it. So maybe that's precisely what's going on in here. So let's actually move it here and then here. Will that change anything? Yep. Yeah, so you set the active unit before you bind the texture, apparently. Okay, so and now I need to have a uniform for an image, right? So in the Fragment Shader, I have a bunch of uniforms for resolution and time. I need to add another one for the image, right? So uniform, there we go. So global variables. Fragile people with CS degree, look away, because yeah, I have a global variables. All right, GL int. So this is the main image uniform, right? Main image uniform. It's going to be 0, and then I want to take this entire thing from here and image uniform. This one is going to be the image. Cool. Does it still compile? Does it still compile? Hopefully it does. Okay, so now GL uniform, right? So let's actually set that uniform to something else. So main image uniform, if I set it to 0, right, I'm setting it to 0, and it's working. If I set it to 1, it's going to be the font. Okay, now we're talking. And furthermore, I can actually have several samplers at once if I want to sort of merge them together, right? So we can try that. I mean, why not? So I'm going to go to the fragment. So in here, I'm going to have and another one is going to be font. Let's have and font. Right. So this is going to be something like this. So because of that, main image uniform, this is going to be uniform, and this one is going to be font uniform, and we'll have to go through the compilation errors to actually fix all of that. Right, so we don't have a main uniform, but we do have an uniform. Right. And in here we're also going to have the font uniform. There we go. All right, so this is a font texture. This is like warnings, nothing special. This one is going to be uniform is going to be 0 initially, and this one is going to be font uniform. This one is going to be 1. So now we have 2 of them, and since we're using it's going to be So now, by the way, let's actually keep running it, because now we're completely in the shader domain, so we can actually hot reload the shaders, right? So we can actually hot reload the shaders. So that means I can quite easily just in a shader switch to a font, and nothing happened. Is it because I'm pressing something incorrectly? No, it is not working. It is not working. Is that because I think I know why? I think I know why we're not Doesn't work. Doesn't work. So, but what if I set this thing to that? Okay. Flag. But I'm using font in here. But I'm using font in here. Why are you? Am I? Okay. So did I make a typo? Did I make a very stupid typo somewhere? No, I didn't. So didn't make a stupid typo anywhere. That's it. It's probably something very, very dumb, and I'm just getting a little bit tired. Please forgive me. I know you probably noticed the mistake. I know you probably noticed some sort of a typo, but from my perspective, sometimes I become blind to these kind of things because I get tired and stuff like that. So let me just sit here for a while, sip my tea, and think about my behavior. So here's the strange thing, right? I'm rerunning this entire thing. I'm using font, right? So in the Fragment Shader, I'm using font as an image, right? But I'm modifying actually. Okay, what if I do it like this? Okay, so this is the one. So here is the here's the font uniform. Here's the and the font. Maybe one of the things I want to do, I want to actually print them. Let me print them. Let me print them. Okay. So this is going to be the font, and after we got them, maybe they don't exist in there. All right. Yes, does not exist because I don't know why. Why uniform does not exist? That's a good question. Because I tried to get this it has triple and here is this thing. Wait a second. Can you have several samplers in? Should be able to. Here's one sampler. Here's another one. By the way, does the output say anything? But yeah, we couldn't get the right. So that's the problem we have in here. We couldn't get the location, even though it's there, even though it's straight up there. Is that because you cannot have several samplers? But I do have. Oh, wait a second. I might be actually using a very old, like GLSL, and maybe in the old GLSL you cannot have several samplers. Let me see. Let me see. Okay, so OpenGL 3.0 has several samplers. Bind sampler. There is a thing called bind sampler. Bind a named sampler to a texture target. Okay, multiple FBOs. I guess it is because of that. It's because of like I'm using this GLSL. I think I need to start using like a more modern GLSL in here. So something that I already use in my game, and that could actually fix this. Because I vaguely remember something weird about samplers, like you cannot have like multiple samplers or something like that. Vaguely. So let's actually use like 3.3 core, right? Yeah, 3.3 core, hardcore, And I don't quite remember. So we're using GLFW, and in GLFW, GLFW. So let me steal some code from one of my projects. Something core. Right, I'm gonna steal this thing. All right. So before you create a window, we're gonna set the version of OpenGL to 3.3 and the profile to core, and hopefully that will do the trick. And something went horribly wrong in here. We still couldn't do a thing. If you're using, okay. So draw array instance no VAO bound. So you are obligated to create VAO if you want to use that. But that didn't help. Look at that. That didn't help. Holy shit. Okay. All right. So let's go back then. Well, I mean, at least I know what needs to be done, right? So my goal was to be able to switch between different images, right? So my goal was always just to switch between different images, and maybe like this specific problem in here does not really matter, right? The specific problem here does not really matter because it's more of like a technical problem, like about specifics of the OpenGL and whatnot. But my goal with this thing was about to understand how to work with several textures and like texture unit and whatnot. And I kind of understand what's going on. Everything else is sort of like details. Maybe it doesn't really matter anymore, right? So we have that, and again, I have to go to the Fragment Shader. So here, we're just going to have an image, right? So I did call it an image. Right? So, did call it an image, and the fragment is going to be something like this. So it's going to be an image. I probably did some sort of a typo. It doesn't really matter on the grand scheme of things. So I'm just gonna, claim this a success no matter what. Right, I'm gonna claim this a success no matter what because I don't really have that much time anyway. Right. Okay, so here's one thing, and if you go to main thing in here, and you switch to a different one. Right, so it's going to be a different one, and it has a different interpolation and stuff like that, and this is what I cared about, like just ability to understand like roughly how all of that works, and think about texture units and whatnot. So then later I can actually embed all of that into my game and enable the text support, right? Because in my game I want to have some sort of a text support. So, right. So this is what our game looks like right now. It's not the final look and feel, but it definitely lacks the ability to display text. I'm thinking maybe I could have like actually went like Jessica Mac route, use Jessica Mac strat, and basically create like a vector font and like draw it with like on the shader part. Yeah, that sounds like an interesting idea actually, because like why not? Could be also an interesting thing to explore. But anyway, so today was an interesting stream. I learned a lot of new things, and yeah, check out the description for all of the references of all of the things we talked about on today's stream. And we have like 15 minutes, but I don't know what to fill those 15 minutes with, so I guess I'm gonna finish the stream right now, because why not? I mean, I did everything I wanted to do. I explored things, I learned things, And yeah, it's time for me to go. Thanks everyone who's watching right now. I really appreciate it. Have a good one, and I see you all tomorrow. Tomorrow, according to the schedule, we're going to be doing programming language development in PRC. And yeah, thanks for watching and thanks for donations. And I see you all tomorrow. Love you. Mwah.